Alright, so let's take a look at question number 3. Number 3 has 3 parts. So it said a 13-foot ladder is leaning against a house when the base starts to slide away. By the time the base is 12 feet from the house is moving at the rate of 5 feet per second. So you have a diagram. Okay, so this is going to be a right angle, and you have a hypotenuse with 13-foot ladder, and then this is horizontal, so therefore it's use x of t, and then this y of t. So I'm going to ask you to stick with the variable or letter they use over here. So let's redraw the diagram, okay, and see the information. So now we have a x of t, okay, and then we have y of t, and this is the ladder. The ladder is moving away, so that means a few seconds later, then you will see the y, the vertical part, getting shorter, and the horizontal part getting longer because it goes sliding away this way. So the x of t is getting longer. Okay, so that means x prime of t is positive. If the length is getting longer, then the rate will be positive. So that means, so we can say that the x prime of t is going to be 5 feet per second, because that is positive. And now we are going to take a look at the ladder. As the ladder slide down, the ladder stay at 13. So let me call this a C. So C of t stay as 13. It never change. So the C prime of t is going to be 0. C prime is 0 because the length of the ladder stay the same. It never change. No change. And then the y of t getting shorter, so we can expect that y prime of t will be negative. So our expectation will be negative for the y prime of t. So now part A, how fast is the top of the ladder sliding down the wall at the moment? So part A, you basically had to find the y prime of t. Okay, so now you have a right triangle. Okay, so we know this is a 13, and then you know that by the time the base is 12 feet from the house, so this is 12. Okay, so how much is this one? So if you remember the Pythagorean triple list, then you would know the number. If you don't remember, you can figure out. So you can say a squared equal to, okay, the c squared minus b squared, so 13 squared minus 12 squared. So a squared equal to 169 minus 144. A squared equal to 25. A equal to 5. So that means y equal 5. Okay, so now we know that x prime of t equal to 5. And c of t equal 13. C prime of t equal to 0. And now we have to find y prime of t. So these are the information. So now, what formula relate all the information together? You have sine, sine, and sine, and you have a right triangle. So definitely going to be Pythagorean theorem. A squared plus b squared equals c squared. But I don't want you to use a squared plus b squared equals c squared this time. I want you to stick with this notation. Okay? So it's going to be the same. So we're going to use a squared, that means yt squared, and then b squared, it will be x of t squared, and the c of t squared. A squared plus b squared c squared. So now we're going to find the derivative. So you're going to use chain rule 2, and then you times the y prime of t. You bring the 2 in the front, exponent 1, and then you multiply the y prime. And then you put the 2 in the front. Okay, so you have x of t, the exponent is 1, and then you times x prime of t. And then do the same thing for here, 2. Okay, you get c of t, and then you times c prime of t. So now, they all have 2 in common, so they are divided by 2. 2 divided by 2 divided by 2. So you have y of t times y prime of t, and plus x of t times x prime of t equal to c of t times c prime of t. So now we are going to substitute information. Y of t equals 5. Y is 5. So 5 times y prime of t. And then x is 12. Xt is 12. And x prime of t is going to be 5. So times 5. And c of t is 13. So and the c prime is 0. So now we get 5 times y prime of t plus 60 equal to 0 minus 60. And then we are going to have 5 times y prime of t equal to negative 60 divided by 5. So y prime t equal to negative 12. And the unit is going to be foot per the time is second. It's one-dimensional. So that means this part is going down by 12 foot per second. This side is getting shorter by 12 foot per second. And then the top of the ladder is sliding down the wall at a 12 foot per second. So the ladder top So the ladder's top is sliding down at 12 foot per second. In other words, the y of t is shortened or decreasing at 12 foot per second. Now I'm going to show you another type of notation. So you're going to use a squared plus b squared c squared. So it will be y squared plus x squared equal to c squared. So we're going to use chain rule, 2 times y to the first power times dy dt, and plus 2 times x times dx dt, and equal to 2 times d times dc dt. As I mentioned before, some people got confused after we reviewed the implicit differentiation. So therefore, I want you to use dy dt, dx dt, dc dt instead of the y prime, x prime, c prime. So this way you will not get confused later on. So now we are going to cancel the 2 because each one have 2. So you get y times dy dt, okay, and plus x times dx dt equal to c times dc dt. So dy dt is going to be y prime, okay, and then dx dt will be x prime, and then dc dt will be the c prime. So one more time, dy dt is y prime, dx dt will be x prime, and dc dt is c prime. So it's just, so we reviewed this concept in the video number 1. So now we're going to do substitution. So we get 5 times dy dt, and then x is 12, x dx dt is 5, and then c is 13, c prime or dc dt is 0. So now we get 5 times dy dt plus 60 equals 0, minus 60 minus 60. 5 times dy dt equal to negative 60, and then dy dt equal to negative 12. And this is one-dimensional, so it will be feet per second. So it's the same answer. So you had 2 different set notation, so you can choose the way that you like. but I want you to know both. Okay. So now let's go to part B. Part B. It said that at what rate is the area of the triangle formed by the ladder wall and ground changing at the moment? Okay, so you want to find the area of these triangles changing. Okay, in other words, you find the A prime. So let's redraw the diagram over here. So we have the x of t, x prime of t, y of t, y prime of t. Okay, we get c of t and c prime of t. So we found the information from the previous part. So we get 12, this is 5, this 0, this is 13, and then we got 5. We found in part A, the y prime is -12, so we put -12. So now you had to find A prime of t. A is area. So now, if you want to find the rate of the area triangle formed, so it basically means A equal to 1/2 times base times height. So now here, base and height. So we say A of t equal to 1/2 times x of t times y of t. So definitely you can see that we had to use product rule over here. So we're going to make u equal to x of t and b equal to y of t. So u prime equal to x prime of t and v prime equal to y prime of t. So now we are going to put 1/2 and then put a product rule over here. So this a prime of t, a of t due to a prime of t. Because all this already have a number, so I'm going to write a number, okay, next to it. So this way it will be easier to do substitution. So x of t is 12, x prime of t is 5, y of t is 5, x prime of t is -12. So now I'm going to u prime times b, we get 5 times 5 and plus 12 times -12. So now we're going to simplify. So we're going to get 25 plus -144, and then you got -119, so it'd be -119 over 2. So a prime of t equal to -119 over 2. This is two-dimensional, so therefore we're going to put first square of v squared per second. So now we're going to use another notation. So we get a equal to 1/2 times base times height. A, and the base is the x, and the height is the y. Okay, each a function of time. So we had to use the product rule. So u equal to x, b equal to y. Okay, so we get u prime equal to dx dt and v prime equal to dy dt. So now because we already know the numbers, I'm going to put over here so that make it easier. So you get x, which is 12, and then this one is 5, and then y is 5, and the derivative is -12. So now we get dA dt equal to 1/2, and then we're going to do product rule. This time this 5 times 5 plus 12 times -12. So now we get 25 plus -144, and then we get half of -119. So we get -119 over 2. Two-dimensional, so therefore you're going to get square feet per second. So that means the area is decreasing at a 119 over 2 square feet per second. So we finished question part B. Now let's go to part C. So part C is said that at what rate is the angle data between the ladder and the ground changing at that moment. So that means you have to find the data prime. You have to find the data of the angle data. So now for part C, so let's redraw the diagram. Okay, so now this is data. So we get x of t, x prime of t. So we got the information. This is 12, this is 5. And here y of t, which is 5. Y prime of t equal to negative 12. C of t equal to 13, C prime of t equal to 0. So now we get all this information. You can find a ratio that relate to angle data. So you can have sine data, cosine data, or tangent data. So you can choose the one that you like. So I am going to choose cosine because these are the original number. If I made a mistake over here, it does not affect my answer because I used my original number. Okay. Now I'm going to use cosine data. So cosine data equal. So for this one, I'm going to use the second set of variable first. Okay, I'm going to swap the order, and then you will see which way is easier. So here's x. This is c. So cosine. Okay, so you get x, y, and c. So cosine will be x over c. So now we are going to find the data of the cosine data, their function of time. Due to cosine will be negative sine data, and then d data dt, because a data is function of time. As I change, the angle change. Then over here, we're going to use the quotient rule. U equal to x, v equal to c. So u prime equal to dx dt, and then v prime equal dc dt. So the x is 12. Okay, x prime is dx dt equal to 5, and the c is c of t equal to 13, and then dc dt is 0. So now we're going to do the quotient rule. So u prime v minus uv prime over v squared. So this times this, 5 times 13 minus 12 times 0, which is 0, over v squared. So it's 13 squared. So let's take care of this part first. So we get 5 times 13, 13 times 13. So cancel, so you get 5 over 13. Now I'll go back over here. I get negative sine data times d data dt. I need to know what is sine data. Let's find the sine data. We already know that this is 13, this is 12, this is 5. Sine data is 5 over 13. He said you already know the number. So it'll be 5 over 13. So you get negative 5 over 13. Negative come from the here. And the sine data is 5 over 13 times d data dt. So now we got, okay, from here. So there's more than one way to do it. Some people already see the answer. So now I'm going to use a method that most people like to use. You multiply the reciprocal, okay? So your negatives, they are negatives. So you get 13 over 5. And then you times, okay, negative. We got negative 13 over 5. So, okay, so this cancel. Then you got d data dt. And then here, this cancel. You got negative 1. So that means the angle data is decreasing at 1 radian per second. The data is always in radian measure because we only use radian in the trigonometry for calculus. Now we're going to use another set a symbol. Okay, so let's see you like it. So we're going to use cosine data. So it would be cosine data uptime. Okay, so over here, my u equal to x of t, b equal to c of t. So we got u prime equal to x prime of t, and v prime equal to c prime of t. And because I already know the number, so I'm going to put the number over here. So we got x of t is 12, x prime of t is 5, and c of t is 13, and c prime t is 0. So I put 0. And then I'm going to multiply, so you're going to do 5 times 13. And then this, you're going to get 0, so subtract 0 over 13 squared. So you get 5 times 13, and you get 13 times 13. So you get, cancel the 13, 5 over 13. Now I finished taking care of the right side. Now go over here. You have cosine as the outer layer, so the derivative will be negative sine. Negative sine of what? Data of t. And then immediately you put data prime of t. So it's very similar. So maybe this set of notation is easier when you have angle, but it's going to be the same thing. So I believe you will understand it because it's basically the same concept. You don't have to do both notation, so you can choose one, okay, and you just get to know both. So now over here, you get sine data. So we use the same concept. You find sine data, which is 5 over 13. So you get negative 5 over 13 times the data prime of t. Okay. And then you're going to multiply the reciprocal. So you times the 13 over negative 5, and then times the same thing. Okay, so this cancel because they're identical. And then you're going to cancel this, cancel, and then you get negative 1. So therefore, it's the same answer. The angle data is decreasing at 1 radian per second. So we finished question number 3.